Scalar and vector quantities, motion, force and work. By the end of this topic, you will be able to describe scalar and vector quantities. If an object is in motion, it is said to have velocity and acceleration. We normally use the word speed to explain the motion, but it does not quantify any useful measurements. In physics, velocity is preferred measure of speed as it can be quantified based on distance traveled. In order to determine acceleration, we need to document any changes in velocity over time. Velocity, the quantity that specifies speed as well as direction of a moving object, is called velocity. One can change the velocity of a moving object by changing the speed of the object, direction of the motion, or both. When the velocity of an object is changing at a uniform rate, then we can calculate the average velocity by taking the arithmetic mean of initial and final value. Example: Kavita runs in a 100-meter long track and she covers a distance of 200 meters in 1 minute by running from one end to the other end and back along the same path. Let us find the average speed and average velocity. Total distance travelled by Kavita in 1 minute is 200 meters. Displacement of Kavita in 1 minute is equal to 0 meter. Average speed is equal to total distance covered by total time taken is equal to 200 meter per 1 minute is equal to 200 meter by 60 second is equal to 3.33 meter per second. Average velocity is equal to displacement by total time taken is equal to 0 meter by 60 second is equal to 0 meter per second. Hence, the average speed of Kavita is 3.33 meter per second and average velocity is 0 meter second. Acceleration. Acceleration is a vector quantity that refers to the change in velocity of an object. It is defined as the rate at which an object changes its velocity. That is, acceleration is equal to change in velocity by time taken. Let the velocity of a moving object changes from an initial velocity u to the final velocity v in time t. The acceleration a of a moving object is a is equal to v minus u by t. The acceleration of an object is said to be uniform when it travels in a straight line and its velocity increases or decreases by equal amount in equal intervals. For example, the motion of a ball rolling down a smooth inclined plane is also an example of uniformly accelerated motion. An object is said to be traveling with a non-uniform acceleration if its velocity is changing at a non-uniform rate. Example of acceleration are a car with increase in velocity, a car which is changing direction while turning as its velocity changes through its speed remains same, a car with decrease in velocity. Acceleration example: a bus is moving with a speed of 60 km per hour. On applying brakes, it stopped in 5 seconds. Let us calculate its acceleration. The initial velocity u of bus is 60 km per hour is equal to 60 into 1000 by 60 into 60 is equal to 50 by 3. The final velocity v of bus is 0 km per hour. Time t is equal to 5 seconds. Therefore, acceleration a is equal to v minus u by t is equal to 0 minus 50 by 3 by 5 is equal to minus 50 by 3 into 5 meter per second square is equal to minus 3.33 meter per second square. Equations of uniformly accelerated motion. Three equations which establish the relationship of uniformly acceleration a with initial velocity u, final velocity v, time t and distance covered s are: equation 1, v is equal to u plus at. Equation 2, s is equal to ut plus half at square. Equation 3, v square is equal to u square plus 2as. Equation 1. First equation which establish the relationship of uniform acceleration a with initial velocity u, final velocity v, time t and distance covered s is v is equal to u plus a. Now acceleration is equal to change in velocity by time, or acceleration is equal to final velocity minus initial velocity by time. So a is equal to v minus u by t, or v minus u is equal to a t, or v is equal to u plus a t. Equation 2. Second equation which establish the relationship of uniform acceleration a with initial velocity u, final velocity v, time t and distance covered s is: s is equal to ut plus half at square. We have average velocity is equal to final velocity plus initial velocity by 2 is equal to v plus u by 2. Distance covered is equal to average velocity into time. S is equal to v plus u by 2 into t, but v is equal to u plus at. Therefore, S is equal to u plus at plus u by 2 into t is equal to ut plus half at square. Equation 3. Third equation, which established the relationship of uniform acceleration a with initial velocity u, final velocity v, time t and distance travelled s is v square minus u square is equal to 2as. We know s is equal to ut plus at square and v is equal to u plus at. Squaring equation 2, we obtain v square is equal to u plus at the whole square, or v square is equal to u square plus 2 uat plus a square t square. V square minus u square is equal to 2a into ut plus half at square. Using equation 1, we obtain from equation 3 v square minus u square is equal to 2as, or v square is equal to u square plus 2as. Graphical representation of motion. Using line graphs, we can study the motion of an object. Line graphs show dependency of one physical quantity on another physical quantity. Example, dependency of distance or velocity on time. Example, a motorbike initially moving at the speed of 18 km per hour accelerates at the rate of 5 meter per second square for 5 seconds. Let us calculate the distance covered by it from initial point and its final velocity. Initial velocity of the bike is u is equal to 18 km per hour is equal to 18 into 100 by 60 into 60 is equal to 5 meter per second square. We need to calculate final velocity v and distance covered s. Acceleration a is equal to 5 meter per second square. Time t is equal to 5 seconds. We have s is equal to ut plus half at square is equal to 5 into 5 plus half into 5 into 5 into 5 square is equal to 25 plus 125 by 2 is equal to 87.5 meter. For final velocity, we have v is equal to u plus at is equal to 5 plus 5 into 5 is equal to 5 plus 25 is equal to 30 meter per second square. Hence, the distance covered is 87.5 meter and the final velocity of the motorbike is 30 meter per second square. Summary. Let us summarize what we have learnt in this topic. The quantity that specifies speed as well as direction of a moving object is called velocity. Acceleration defined as the rate at which an object changes its velocity. Three equations which establish the relationship of uniformly acceleration A with initial velocity u, final velocity v, time t, and distance covered s are: equation 1, v is equal to u plus at. Equation 2, s is equal to ut plus half at square. Equation 3, v square is equal to u square plus 2as.